Hi everybody, and welcome to your first video lecture of IB Biology. This first unit we're going to be looking very closely at cells and the evolution of the cell theory. Obviously we're going to be looking more closely at what's inside cells and what those little things inside the cells do. We're also going to be looking at how cells evolved from the oldest cells that evolved to the newest ones. Okay, so the first unit is really kind of just an orienteering exercise. We're going to be just introducing the very key ideas. And this first video is going to focus on looking at microscopy and how to use microscopes. So this is a key skill which you'll need to use all the way through your IB biology course. You may do an IA that focuses on doing microscopy. And so obviously we have some pretty good microscopes these days. So it should be quite a bit of fun for you to actually do it. Anyway, let's get started. So hopefully you'll remember that you have a microscope. Microscopes can be monocular or they can be binocular, which means they have two eyepieces. You have objective lens, you have a stage, which is what you mount your slide onto. You have a light down here, which sends a light up through here, an on-off button which turns the light on. Obviously your objective lens you can rotate and they usually appear, you've got a ×4, ×10 and a ×40, and if we're using the bigger microscopes you'll often find that they've also got ×100. Your eyepiece lenses, which are these ones up here, generally have a magnification of ×10. So remember to get your total magnification, you multiply your eyepiece magnification by your objective lens magnification, okay, to give you your total magnification. You should always record your total magnification whenever you do a diagram or a microscopic diagram. Over here you have your focusing wheel. Now most obviously with things with microscopes are best off done practically, and so we'll be covering a lot of this stuff again in class. So don't worry too much if the video's going quite fast. Okay, here, this image over here, you can see you've got a specimen down the microscope. It looks like something that's to do with a plant, because you can see these green areas which look like chloroplasts. And you can see you've got a bit of a scale running along it. So what will be different from IGCSE is when you look through your eyepiece lens, you should have a scale down there. And that scale will be used to help you calculate the actual size of what it is that you're looking at under the microscope. Okay, so we'll be focusing on that as a key skill. Okay, something that you will have to do in exams and obviously as classroom activities is calculate the magnification of an image. And so you might need to do that, you need two things. You need the image itself. Okay, so you can see in this image you've got something called Alodia, which is pondweed. It's a plant species. Okay, so you can see chloroplasts inside it, you can see a cell wall, you can see the cell membrane, so it kind of shows you that it's a plant cell. And it's got a scale on it, so what you will see will always have a scale, and you need that scale if you want to find out. And so we're going to come across a unit now that you may not have encountered before, which is a mu, this symbol here. It's kind of like a back to front U. Okay, and in biology, or as a unit, it means micro. Okay, so we often call this unit microns or micrometers. You can use either word, but the symbol is always mu-m. Okay, so what do we do? So we've got our scale bar, okay, showing us how long it is, and we've got our image. Okay, if you've got both of those two things, you can calculate the magnification. So the first thing you need to do is convert your scale bar, or you need to find out how long your scale bar is in millimeters. So you get your ruler, you put your ruler against the scale bar and you calculate how many millimeters it is. Now notice I said millimeters and not centimeters. The reason is it's much easier to go from millimeters to microns and microns to nanometers and millimeters to meters than it is to go into centimeters, because you've always got a factor of 3 zeros between each one. So if you've got 1 millimeter, that 1 millimeter is worth 1,000 microns. Okay, so if our ruler is reading 20 millimeters for 10 microns, okay, it's going to be 20, okay, we're going to have to convert our, lost my train of thought then. We're going to have to convert our 20 millimeters into microns. So we take 20, okay, and we multiply it by 1,000, which gives us 20,000 microns. Okay, so now we have our scale bar measurement, which is 20,000 microns. We know that our scale bar is 10 microns, okay, and we divide one into the other. And obviously you can see you've got a magnification of times 2,000. Now, at this point in time, what I'd like you to do is pause the video, and just using your screen and a ruler, you need to calculate the magnification of these scale bars, just as a little bit of practice. So pause the video now, and then you can carry on afterwards. Okay, so continuing. All right, so this is one type of question you might encounter. This is another type of question you might encounter. Okay, so what you might need to do in this one is say calculate the actual size of an organism. Now that's pretty simple. It's nothing too tricky, but it's easy to get mixed up with the numbers. Okay, there's a basic equation that we have to use. Okay, and for this equation you can use a triangle to help you remember it. And the way I always remember it is I am. Okay, so image length is actual length times the magnification. Okay, so I always equate it to the Indonesian word for chicken. It helps me remember the equation and in which order things come. So maybe you could use that as well as a helpful way to remember it. So if we need to calculate the length of an image, we've got the actual length and the magnification, we just multiply those two together, and that will give us the image length. If we want to calculate the actual length, and we have the image length and the magnification, or maybe you have to measure the image length, you just measure it, okay? Divide it by the magnification, and that will give you the actual length. But remember to present your work in the most appropriate unit. So let's go back to the example. In this one here, look, you're given the magnification, which is 90,000, okay? You are given, here you've got a ruler and you've got an image. And so you line the two up, okay, and you can see that this is measuring 80 millimeters. Okay, so if we take 80 millimeters and we divide it by our magnification, okay, we get 8.9 times 10 to the minus 4, or 0.00089 millimeters. Now, obviously, that's giving us the actual size of our specimen, or the thing that we're looking at. And so millimeters isn't going to be the most appropriate unit. So here we could do one of two things. We could convert it into microns. Okay, so we can take our millimeters and divide it by 1,000. Okay, to give us 0.89. Okay, or go to nanometers, which is by multiplying it by 1,000,000, so an extra 3 zeros. So you can see here that it's best to give us clear whole numbers instead of decimals. Okay, so but if you used either of these two units to do the specimen, that's absolutely fine. Okay. All right, so there's that equation again. Record it, write it down, use it when you need to. So here's some images. You can see here that you've got a line across each one, and you've got the magnification. So obviously what you need to do with this is pause the video, use your ruler, measure the image length, and using the magnification to calculate the actual length of the specimen. So you can pause the video, do that now, write down your answers. Here's another question for you. A sperm cell has a tail that is 50 microns long, and a student draws it 75 millimeters long. What is its magnification? Again, pause the video, do it now. Here's the answer. Okay, we're going to stop the video there. That's our first little video lecture done on magnification. Okay, and tomorrow when you come into class, we'll be doing some work on actually utilizing these, using the microscopes, and doing a little bit more practice. So, thank you for watching, and we'll see you later.